All right, so we've done some graphing the last couple days. Um, so we're going to start talk today about what's called transformations. And really, it's a transformation describes how a graph moves. So if we had the graph y equals x, okay, and this is what's called a parent graph, because there's no numbers. There's no like plus 2 at the end or a 5 in front of the x or anything like that. And the parent graph for y equals x, 1, 1, 2, 2, 3, 3, because y equals x. They have to be the same. Okay, and so it'll look like that. A little bit crooked, but you get the idea. So then when I start to put numbers in the problem, like so if I put a plus 2 at the end, if you think about slope-intercept form, the 2 was the intercept. It goes through the y-axis at 2, and then the slope is 1. In front of the x is really a 1. So we would go up 1 over 1, and the line looks the same. It's just up 2. So the 2 is a transformation. It moved the graph up 2. If I did y equals x minus 3, it means this minus 3 at the end means move everything down 3. And the graph will look the same, just down 3 spaces. Okay? And so another way to write this situation is is using functions. So we could have f of x equals x. That's the same as y equals x. And then what it's going to another way to write it, is to say that the new line, we'll call it g of x, equals whatever the f, like the original line was, plus 2. So that means the same thing. If I did g of x equals f of x minus 3, that means the same thing. This just means take the original line, whatever that looks like, this one, and do minus 3 to it. So the blue one goes to the blue one. This means take the original line, this one, and do plus 2. So that's the red one. Okay? So these transformation things we're going to use in this chapter. We're going to use again in like the next section. We're going to use it again in chapter 6, again in chapter 9. So it's going to come up different like times. Okay? All right, so we have 3 different types of transformations. Actually, before I do that, here's kind of a theme that will happen. So if you have a number on the outside of the parentheses, it moves the graph up or down in some way. Okay, and you'll see what I mean when I do some examples here. If you have a number on the inside of the parentheses, you're going to go left or right. But opposite. And again, you'll see what I mean in just a minute by the word opposite. Okay, so we have three different transformations. First, we have a translation. A translation moves up, down, left, or right, like in a straight line, depending on where the number is. So here's kind of the way that the problems will look. You'll have some beginning line, and truthfully, the beginning line does not matter. I could write whatever I want over there, and it doesn't actually mean a thing. It's the second part that's most important. Okay, this is really the important part of the whole problem. Okay, the directions are going to say to graph. You don't need to graph. I just want you concentrating on what does that plus 3 mean? Okay, the numbers on the outside of the parentheses, it's over here. It means the graph is going to go up or down. Positive 3, that would mean go up. So this one is a translation up 3. Okay, if I had one that said f of x minus 4. Okay, this is the important part. I didn't even write anything over here. I don't even care. I'll write the same thing just so that, because that's the way the problems will look. But I don't even need to look at this. I just need to look at that part. Okay, parentheses on the outside. I'm going to move it up or down. Translation down 4. Okay. So the other thing that I forgot to write, my apologies, translations moves the graph. It moves it up, down, left, or right. And translations are always adding or subtracting, because we're going to do another one in a little bit where the number's on the outside and it's not a translation because it's not adding or subtracting. Okay? All right. So if I had 1/2 x minus 4, remember, I don't even care what that is. Okay. So numbers on the inside. So go back up here. Number on the inside of the parentheses, it's going to go left or right, but opposite. Okay, so I'm just really looking at this part. So this is a translation. And normally you would think, well, positive 2, like on a number line, positive 2, that goes to the right. I do the opposite. Left 2. Okay, and if we plugged in a bunch of numbers, I could show you how that actually works, but right now I'm not interested in that part. Okay, so there is just a bit of like memorization going on here, and I'll show you more how that works on a different day. So if we had that's what I'm looking at. -1. -1 would mean go to the left, but when it's on the inside, I do the opposite. And I go to the right 1. Okay. So here's, you'll have some problems, just the numbers will change. But here's like a perfect, okay, when the number's right there, what do I do? And so it should, just change the number for your answers on some of these problems. Okay? All right. To earlier, I said this. Number on the inside, left and right, opposite. Okay. Okay, all what I just kind of boxed up, that's the only thing you need. The next thing we have is called a reflection. Okay, and reflections flip over. Excuse me. Okay, and the reflections, here's the big thing. If it's a reflection, you're going to look for a negative sign. Not subtraction like we did on the other one, but a negative sign. So again, I don't care what comes first. So negative signs come at the beginning or before. Subtraction signs come after. Okay, so again, remember we said on the outside it was up and down, and on the inside it was left or right. Okay, from the last slide. So the negative sign is on the outside of the parentheses. So this is, what kind of transformation is this? This is a reflection over the x-axis. Okay, so some of you are maybe thinking well, the x-axis goes left to right, but he said outside meant up and down. So what we're really talking about is, let's say I had a line that went like this. Okay, well, when we do a reflection, this negative sign in the front, what'll happen is this point that's down low on the bottom will flip up to the top. It's 2 spaces away. It went up and down. And this one over here is 1 up, so it goes 1 down. And so the line, it'll make an X. But everything over here on the left side flips up higher on the left, and this one that's higher on the right flips down. Okay, so that's kind of the reflection that we're talking about. If it was, again, this first part doesn't matter. negative sign in the inside. Okay, this one means a reflection over the y-axis. So if we started, I should use blue for the red one. Kind of color coordinate things. Okay, so if we start with the black one and we did this green part, reflection over the y-axis, it means it reflects over here. And in this one, it's on the y-axis, so it actually doesn't move. It just stays there. And the x looks different. So you can see it changes how the line will end up looking. They look both very similar, like the blue one and the purple one, or excuse me, the blue one and the green one. But one rotates in a different direction. Okay, so you can see like the one that went over the y-axis, like the lines cross on the y-axis, and the one that went over the x-axis, like it's just the spacing's a little bit off, but it intersects on the x-axis. That happens a lot. Okay, so reflection. Outside means reflection over the x-axis. Inside means reflection over the y-axis. Okay. All right, and then probably reflection over the x-axis, reflection over the y-axis. Do the hardest like one. We have what's called a stretch and a shrink. So over here, and again, we're still going to do outside means up and down. Or vertical, and inside means left or right or horizontal. So I want to write something here to kind of talk about what things actually mean. So when we had our y equal x line, or f of x equals x, it's the same thing. Everything was identical. 1, 1, 2, 2, 3, 2, or 3, 3, 4, 4, and so on. And you could do the same down here on the left side, but I'm just going to leave it right there. Okay, so let's just say we did have f of x just equals x, and then g of x equals 2 in the front, like that. So stretch and shrinks involve multiplying. Okay, so this is a 2 in the very front of the graph, not like plus 2 at the end. Remember, plus 2 means translation because it's an addition. Okay, this one is what's called a vertical stretch by 2. Okay, what the heck does that mean? Okay, well, it just means that vertical means up and down. Okay, it just means instead of going over 1 and then up 1, we would go up 2. Instead of over 2 up 2, we would go up, instead of up 2, what's 2 times 2? We would go up 4. Instead of over 3 up 3, what's 3 times 2? 6. Okay, and so you had this y equals X line. And then when we did a stretch, the points got farther up or farther down if we went this way. So it's kind of like slope. The stretch and shrink, when we think about a line, it's like slope. Okay? So if we did 1/2 f of x, okay, this one is a vertical shrink by 1/2. And I'll come back to in just a second. Why did I use stretch? Why did I use shrink? Okay, so a shrink means we're going to go less. We're going to go how much less? We're going to go half. So instead of over 1, up 1, what's half of 1? Well, that'd be a half. Instead of up 2, what's half of that? Half of 2 is 1. Instead of over 3, up 3, it's half of 3, 1.5. Instead of over 4, up 4, what's half of 4? 2. And the line gets a lot flatter. Okay, so shrink and stretch. So here's kind of a big thing. Greater than 1 means stretch. Less than 1 means a shrink. Okay. All right, so one more thing about stretches and shrinks. Greater than 1 meant a stretch. Less than 1 is a shrink. Well, 1/3 meant a shrink. Okay, the vertical stretch by 2, vertical shrink by 1/2. So we talked about, we didn't talk about what happens if the numbers go on the inside. Okay, so remember all the way back, there's the number on the inside. It is going to go left or right. Okay, so remember inside means left or right, but opposite. Okay, so here's kind of the tricky part with this. Okay, this is what's called a left and right means horizontal. The 2 on the previous, but left or right or on the inside means do the opposite. So instead of a stretch, it's going to be a shrink. And I need to do the reciprocal of the 2. So everything kind of gets done the different direction or opposite. Okay, so if I had g of x equals f of 1/3 x. Okay, well, it's on the inside, so that means horizontal. 1/3 shrink, but I do the opposite. Stretch. And I flip over the number. I should put by 3. How much is it stretching? It's stretching by 3. Okay. So if it was, before I write that down, let me see if it even happens the way that I was going to write down. It doesn't happen that way, so I'm going to leave it. Okay, yeah, I was going to put like a 2/3 type of fraction, but you'll only see like 1/2 and 1/3, just with a 1 on the top. Okay, so it's a lot of information. Translation, reflection, stretch, shrink. Okay, all the problems that you're going to do today, in the directions, it's going to say graph. You don't have to graph. All I want you to do is describe the transformation. So like this would be the answer. This would be the answer. Okay? So just do the best you can. We're going to be using these words again in section 7. We're going to graph absolute value, and we will talk about doing the stretches and shrinks and translations and all that kind of stuff. Okay? There's some okay examples, like in the book, that show similar things that I showed in terms of like reflections and translations and stuff like that. So look at the examples in the book also. Don't just 100% rely on the videos. Okay? Rewatch parts of it if you need to. Okay, this is something that we're going to keep talking about throughout the years, so it's not going to go away. All right, the more you practice it, the better you get. I'm expecting it to be really hard today, just because it's the first time you've seen this. And then as we do it more and more, it'll become a little bit easier. All right, have a great day, guys. Give it a shot. See you tomorrow.